Okay, so in this video, what we're going to do is look at how we can use rectangles, either left or right. In our case, we'll probably use left rectangles to approximate the value of an integral. All right, so let's start with this integral here. We want to look at the integral from 0 to 1 of x squared plus 2. All right, so this is what we are wanting to approximate. And we're going to use 4 left rectangles. Okay, so remember that when we do this, we're going to have, this is going to be an approximation because this function, this quadratic function, has some concavity to it. And so if we think about the image of this or the graph, it's going to look something like this. So what we're going to have, if we look at this here, we're going to have rectangles of width 0.25. So let's go back here. If we're using 4 rectangles from 0 to 1, that means that delta x equals, in general, b minus a over n, which in our case would be 1 minus 0 over 4, because we're using 4 rectangles, which is equal to 1/4. So that means each one of our rectangles will have a width of 1/4. All right, so when I'm drawing this, this is going to look like this. The first rectangle is going to be this one right here. Let me change this to here. And the second rectangle would be this one right here. The third rectangle would be this one here. And then the fourth rectangle would be this one here. And you will note that this is going to be an underestimate. If we think about what's happened here, there's this little bit of area here that is, not being captured by our rectangles, and so this is going to be an underestimate. Okay, so when we look at this here, we know that my delta x is 1/4, so we're going to have 1/4. Now, since we're using left rectangles, if you think about it, the first rectangle starts at x equals 0, so that's going to be the height. Okay, so we would have f of 0 plus f of 0.25, and that's because we're scooting over 1/4 every time that we do this, plus f of 0.5 plus f of 0.75. So those are going to be my 4 heights. So remember, these are all heights, and each one of them has a width of 1/4. So this would be 1/4 times, now if I plug in 0 into my function, I get 2 out. If I plug in 0.25, so that's a quarter, 1/4 squared is 1/16 plus 2, so that would be 33 over 16. Plus, now if I plug in a half, that's going to be 1/4. 2 plus 1/4 is 9/4. And then if I plug in 3/4, that's 9/16 plus 2 is going to be 41/16. Okay, so this would be 1/4. Now, I've got a common denominator of 16, so that's 32, plus 33 is 65. Got to multiply that by 4, and so that gives me 36. 36 and 65 is 101, plus 41 is 142. So 142 over 16. Okay, and then that's going to give me 142 over 64. I can reduce that to, if I divide it by 2, I get 71 over 32. So that would be my approximation for the integral from 0 to 1 of f of x dx, or the integral from 0 to 1 of x squared plus 2 dx. And again, that's left rectangles, and again, that's going to be an underestimate because the function is increasing. And remember what we said, anytime that the function is increasing, since f is increasing on 0 to 1, left rectangles will be an underestimate. Okay? All right.